Hello, I'll be explaining my code implementation of the lending platform. Based on the flexibility allowed, I decided to build all four services, which is the core banking system, the lending management system, the middleware, and the scoring engine. So the CBS, simply the core banking system, simulates the core banking system by providing the know your customer information plus the transaction data. The scoring engine will calculate the loan limits and the credit scores based on the transaction data provided by the CBS. Third service, the middleware, it will connect the LMS to the CBS, the scoring engine, handling the authentication and the data retrievals. Lastly, we have the lending platform, which will handle the endpoints to allow the customer to subscribe, request a loan, and check the loan status. The project was built using Node.js and Express, and it's linked to a cloud database, MongoDB. Each server runs on its own, so we have 4 servers running separately for each service. This is to simulate the real-world processing of the whole system. I'll explain how the code works for each server, and at the end we'll test each endpoint, the subscribe, the request loan, and check the loan status. So first we'll start with the core banking system, which I said earlier, it simulates the core banking system by providing the KYC data and the transaction data. The KYC data is provided to the LMS. This is during the subscription of the user. And the transaction data, this will be provided to the scoring engine, which will help in determining the loan limit and the credit score. So to simulate a real bank situation, I had several functions. The get random number, get random int, and the get random timestamp. These will help generate random data for the customer and the transactions. So I have the XML for the customer defined. The data for the customer are as follows. We have the when the user was created, customer number, date of birth, we have the email, we have the first name, gender, ID number, etc. For the transaction, these are all the XML data defined so that our SOAP requests could go through. So for the transactions, we have the account number of the user, which the transaction to which the account is related to, and more. The alternative channel transaction amount. This is based on the document that was submitted during the test. So I just simulated it. So that data, this XML defines the structure of the customer and the transaction. So on our service, we define, so we generate each customer, generate random numbers. So for example, the monthly income for the user, it's not hard-coded. I made it into a dynamic monthly income. So it will generate a random number between 2,000 and 10,000. We also have the gender. The get random int will help generate a random integer, which will later assign female or male to the customer. So with all this, the randomness, it makes the data more dynamic, so it makes the simulation better. So to the transactions, also do the same to the transactions. So after picking up the transaction, we give it an account number based on the customer number, and we generate all the money transactions data are all generated randomly based on limits that I've specified. So at one point, a user can have one specific data to themselves. I've also exposed the two endpoints, one for the customer and one for the transactions. So the one for the customer, this one will be called from the LMS, and the one for the transaction will be called from the scoring engine when determining the loan limit and the credit score. Okay. The second one is the scoring engine. We can start the server for the core banking system. While the server is starting, we can talk about the scoring engine. So in the scoring engine, I've defined two objects. One stores the registered clients, which in our case will be the middleware, and the scoring data. This will be the tokens. So we have several endpoints. Let's see. So the first endpoint is to create a client, which in our case will be the middleware during its registration. The second endpoint will be we want to initiate a query score. This one, it initiates the scoring by fetching transactions from the middleware and calculating the limit amount the user can be given. And we've used several strategies. So for example, the positive factors, I use the average monthly balance. So we get some multipliers to determine the limit amount. We have the total alternative credit. So we get multipliers that will help in determining the loan limit for the user. And we have around 4. One is the total alternative credit. We have the total credit transaction, the average monthly balance, and the total bounced checks. So we consider both the positive and the negative factors. So for example, the total bounced checks have the negative factors. This is just a simple way to determine the loan limit. You know, on a large scale of production where there's more complex ways to handle this. So the transaction we are using to get all this, the transaction that we get from the core banking system. So we make a SOAP request to the CBS and it returns the randomly generated transactions data that we had before. Then it picks up all the data calculated before and finds so for example, we have the balance multiplier. it will increase the loan limit by 10% for every 1 million in it. The risk penalty, it will deduct 5% from the loan limit based on the checks that bounced. Then from all that, we generate a score token and determine the limit amount the user can be given, and we send it to the middleware. Now to the LMS. The last endpoint, I had it customly made, which it's not basically part of the requirements, but I wanted to make the token retrieval more dynamic instead of copy pasting it from the LMS to the scoring engine. So I added an additional endpoint to fetch the token generated by the scoring engine. So the LMS automatically requests for the token, and the token is sent to the LMS instead of copy pasting it every single time you make a request. Okay, so then the next one will be the middleware, which we said it will be the bridge between the scoring engine and the CBS. So let's see, middleware. Okay, so the mock, our banking system server is running. We can start the scoring engine server. So we have our mock server running on port 8093. So our middleware, before we move on, I have environment variables defined on the middleware. We have the username and password for the core banking system. These are the credentials that we'll be using to access the CBS. We also have the one for the middleware. These are all custom, so it doesn't matter. We also have an API key. This one will be part of a header when you're making our request to the scoring engine. This will help in the authentication of our requests. So the middleware, jump into bucket. So in the middleware, we have a function to register our middleware to the scoring engine. And we're using the middleware username and the password, the one which we just saw on the env file. So we make a request with our payload data to the create client API, and it returns the token. So the token will allow us to make future requests easily. We are easily authenticated. Also on the middleware, we have the endpoint to fetch the transactions. These are the transactions that we fetch from the CBS, the core banking system. We also have the last endpoint. They want to fetch the token, yeah. The token I just explained before. So we don't need to be copy pasting the token back and forth. So I initiated it to get the token. Then we start our middleware. So we can start our middleware server. While it waits, we can go to our last service, which is the LMS, the lending management system. So basically it will handle all the endpoints, which is the subscribe, loan request, and checking the loan status. So before we continue, you can see from the console logs, the middleware has registered successfully with the scoring engine and a token given out. So meaning we are authenticated successfully, and all our requests will actually go through. So this will help us make requests successfully. So on the lending management system manages customer subscription, the loan requests, storing data in the database. For this instance, I used MongoDB. So there's a URI given out during the setup. Here's the URI. This is the username and this is the password. These are the ones. This one is API key we saw before for our headers. So we connect to our database and define two schemas. So the first model will be for our customer. It will handle the customer number and the know your customer data. This is the data that was sent to us by the banking system. We also have the loan schema. This will store the loan data that the user will request, or it will be ongoing. So we have the customer number, the person who requested the loan, the amount he requested for, and the status. So currently it's defaulted into a pending. Depending on the limit amount, it will either be approved or rejected. So we also have the request ID in the loan amount. This will be like a timestamp to help us make the loan status. We also have the scoring token. This is the token that verifies the process during the determining the limit amount, the token that was used during that process. Okay, so we have one function for the fetches the scoring token. We also have so this one for fetching the scoring token, which will determine, which will uniquely identify the process during which the limit was determined. Then we have the query, the function to query the know your customer data. We create a soft client and make a request to the core banking system. So this is the endpoint that we use, not the endpoint, the function that we'll use to query the more information about the customer. So we'll use the customer number. It's been passed at the parameter. So once we get it, we'll return the data. We also have the function to query the scoring, and the one to query the score, which will determine the limit. We implemented the amount of retries it can make. We have the actual token that will verify our request. The maximum number we want to verify, we want to make the request, so we initially have it at 5. So the function will make 5 attempts to get the query score. Then if you don't get it, it will change the loan to a reject, but it will at least try 5 times. Okay, let's see. Oh, okay, so now we have the endpoints, the one we're supposed to test. We have the subscribe, which will subscribe the user. We have the one to request for a loan and the one to check for the status. So the one for subscribe the customer, we'll pass the customer number. We check if the customer exists. If he already exists, we say the customer already exists. If he doesn't, we make a request to the core banking system to send us the information about the user using the customer number. If we get it, we save the customer number plus the information we have received. We can test it out right now. Let's open the Postman. We can also start our LMS server. So our LMS will be running on localhost. Okay, our LMS is running on localhost 3000. We're trying to subscribe a user, so we'll be passing the subscribe needs customer number. Our customer number, so using the data, the let's see which customer we have. So the first customer ID for testing will be this one, 2347. So we want to subscribe this user into our system. It's a post request, and we send the request. So get a response. The customer has been subscribed. And if we head over to our MongoDB database, currently I haven't refreshed it, but you can see we don't have any customers. Okay, so I've refreshed it. We have the customer number we just made the request with, and the know your customer data. So we have a customer number. This is the data received from the core banking system. So we have the customer number, their first name, their last name, their monthly income. So remember, this was randomly generated using our generate random number function. We also have the gender. This was generated. The gender is determined randomly using the int. So based on 0 or 1, it determines it's male or female. This simulates a real world banking system. So you can see we have our data successfully stored in the database. So the endpoint works. Okay. To the next endpoint. So moving on to our next endpoint. Our next endpoint will be the one to request a loan. So it accepts two parameters, which is the customer number, the one who wants the loan, and how much he wants it. So first we check if the customer exists in our database. Secondly, we check if they have any ongoing loan pending or approved. If so, we deny them. But if they don't have any loan, we proceed to fetch the scoring token. So during this process of fetching the scoring token, we fetch the token from the scoring engine. This will help us successfully or authorized our requests when we are determining the limit. So after getting a reply, we create an instance of our loan, but we give it a pending because we haven't checked yet the limit the user is actually successful, but we create an instance. Then we also store the scoring token which we receive. So if we want the score data will have the limit and the score. So we're making using our query score function. This is the token that will authenticate our request. 5 stands for the maximum times we want to redo the request. 2000 is the number of seconds we will delay before making the retry. So if we get our score data, which will have both the score and the limit amount, we'll compare if the amount the user wants is less than or equal to the limit amount. So if the user requested for $10,000 and the limit is $100, well, we'll reject it, else we'll approve it. Else the default one is the rejected. We don't get the score data, or the request to get the score token fails, we'll reject it. So here we are actually changing the loan we already had before this one, because initially we set it to pending. So once we get our data, the limit amount, we check it and confirm it to the amount the user had requested. If it's less than the limit amount, then we approve it, else we'll reject it. So we can test that one out. Is it? So the endpoint is loan request. It's expecting an amount. Let's say we want 20,000. Yeah, we have the customer number and the amount. So it's a post request. So this is the user making a request for 20,000. Okay, it was approved. So before you forget, the transaction data that is used to determine the limit amount, they're all randomly generated. So for this instance, the user amount was less than the limit amount. So we can confirm from the database if we have the amount saved. You can check the loans. So yes, we have one document with the for the loan. We have the customer number, same one, the amount that you requested for, and if it was approved. We also have the request ID, which is the timestamp. Can use this later. Let's just copy it. Okay, moving on to the next endpoint. We'll test out the loan status first, then I'll try to manipulate the amount so that we can have a rejected status. So the next endpoint is the loan status. We're checking the loan status if it's so rejected, approved. So it's accepting a request ID, and using the request ID, it finds a loan status with that request ID. So it doesn't need a body. Status. It's a get request. Let's use this. We paste in the request ID for the loan that was just approved. If you check the status, yes, here it is. Here's the loan status. We have the request ID, the amount, and the status. That's what we are currently returning as a response. Okay, so we'll simulate a scenario where the loan was rejected. Let's undo this. We'll try with a different user ID. So we'll subscribe a different user and make sure this loan is rejected. So let's get a which user do we want? Use user 3184. So we'll subscribe a new customer, the different customer number is successfully subscribed. If we check our database, let's check it. If we check our database, refresh it, check the customers. We'll have two customers. This is the one we have just added right now, and you can realize this time we have a male. So last time we had female, this time we have a male customer. The function to generate randomly, it's helping us simulate a real-world banking system. So this is the data that was returned. So we have a second user. We can try requesting a loan using that user. Customer number. So we want to request a loan using that this time we'll make the amount a bit bigger. So the user, let's make amount to, let's give it a big number so that it gets rejected. Yeah, hope that will work. So I'm making a post request, we're requesting a loan. So this particular user ID number 3184 is creating a loan. Yes, got this same simulation wanted. So the loan was rejected. So if the loan was rejected, he can actually apply again for another loan. This time let's say let's give it a different number. Let's say 4,500. Let's say 45,000. If it's rejected, he can apply again, but if it was approved of pending, it won't be accepted. So let's see. Yes. So since it was rejected at first, the second one he reduced the amount to 45,000. This time it was approved. We can also check that. We can check the status of that loan. We have the request ID here. You can check this loan status. Don't need body. So our request ID is that it's a get request. Want to check the loan status, and yes, here it is. If we head over to our database, we can refresh it. We can check the loans. So this is the first one we had. The one that was rejected is this one. MongoDB is kind of stored there. The initial amount was kind of too big. So this here is the data for the rejected loan. Then the user reduced the amount and it was approved. Okay. So I've successfully implemented our lending management system, and all the 4 services communicate and provide data to one another. So for a recap, the mock customer, the core banking system handles providing the customer data and the transaction data to the customer data to the LMS and the transaction to the scoring engine to determine the limit. The scoring engine registers on startup with the middleware. So this project can easily be installed using npm install. You'll have to install the dependencies for each folder. I haven't removed the keys, the secret keys, to make it easier for testing. But in a production environment, I'll probably git ignore it the same way I've done here. It won't be pushed to the GitHub. Okay, and that is all of it.